This is Litika, Assistant Professor from Computer Science and Engineering Department. Today we are going to see about Dijkstra's algorithm. Dijkstra's algorithm derived by the Dutch computer scientist in 1956, which is used to find the shortest path from the single source to other nodes in a weighted graph with non-negative edge weights. What is Dijkstra's algorithm? It is a popular algorithm for solving single-source shortest path problems having non-negative edge weights in the graph. That is, to find the shortest distance between two vertices on the graph. Where can it be applied? It can apply both on directed graph and undirected graph, as this algorithm is designed to work on any type of graph as it meets the requirement of having non-negative edge weights and being connected, and fails on a graph with negative edge weights. Directed graph. It indicates the direction of travel between the vertex connected by the edge. In this case, the algorithm follows the direction of the edge when searching for the shortest path. In undirected graph, the algorithm can traverse both forward and backward along the edge when searching for the shortest path. How it works? It initializes the distance as 0 source node and all other nodes as infinity. Pick the unvisited nodes with the smallest distance. Update the distance for all neighbors if the shortest path is found. Marks the current node as visited. Repeat the step 2 to 4 until all nodes are visited. Example: Dijkstra's algorithm will generate the shortest path from the node 0 to all other nodes in the graph. For this graph, we will assume that the weight of the edge represents the distance between two nodes. The distance from the source node to itself is 0. In this example, the source node is 0. The distance from the source node to all other nodes is unknown, so we mark all of them as infinity. Step 1. Start from the node 0 and mark node as visited. In step 2, check for adjacent node. Now we have to choose either node 1 with the distance 2 or node 2 with the distance 6. In this step, node 1 is the minimum distance adjacent node. So mark it as visited and add up the distance. Now the distance will be node 0 to node 1, which is equal to 2. Step 3. Then move forward and check for adjacent node, which is node 3. So mark it as visited and add up the distance. Now the distance will be node 0, 1, 3, which is equal to 2 plus 5, 7. Step 4. Again we have to choose 2 for adjacent nodes. Either we can choose node 4 with a distance 10 or node 5 with a distance 15. In this step, node 4 is the minimum distance adjacent node. So mark it as visited and add up the distance. Now the distance will be node 0, 1, 3 and 4, which is equal to 2 plus 5 plus 10 equal to 17. In step 5, again move forward and check the adjacent node, which is node 6. So mark it as visited.